remember from the other day, if we want to find the area between two curves on an interval from A to B, we can use this formula here, where f of x is going to be our top function, g of x is our bottom function. And this, for this to work, f of x has to be above g of x the whole time. And remember, a is the leftmost point on our interval, and b is the rightmost x value on our interval. This type of area where we have a function above the other one the whole time, basically, if we think about definite integrals and how we started learning about area under the curve, we used rectangles. And we took a bunch of them and added them up to approximate area under a curve. So here it's kind of the same thing, but the rectangles are between these two curves. And since these rectangles are vertical and are very thin, their change in x is used as dx. That's what we're using in our integral here. And we call this a dx cut because it has vertical rectangles. Again, we only do this with dx cut vertical rectangles only if one curve is always above the other one. Between A and B. So as long as between A and B, f of x is always above g of x, we can do this. But if they're not like that, we can't break it down this way. Sometimes what we need to do is look at it a little differently. If you look at the curve down here, the two curves, these, one is not above the other one the whole time. In this case, actually, we end up having this curve f of y, x equals f of y, is always to the right of our other curve. So in this case, what we end up having, to figure out this area, we have little horizontal rectangles. We add these up. Again, with a definite integral, we can do that, add up a bunch of them, limit as n approaches infinity of all those rectangles. But this time, our thickness of those rectangles is a change in y. This is called a dy cut. And we have horizontal rectangles. In this case, we do this if one curve is always to the right of the other one. From C to D. So one curve is always to the right of the other one. In this case, it's a dy cut. Everything in here is going to be in terms of y. Our limits here, lower and upper limits, are in terms of y. The C is our bottom y value, our lowest y value. D is the top y value. And this one, f of y, is going to be the right function minus the left function.